Okay, number 38, they show us this spinner, and you can tell that some of the parts have a larger probability than some of the other ones. Like this piece and this piece are bigger than the others. So they're going to give us hopefully just enough information that we can figure out how big they are or what percentage of the total circle they are. So sectors C and D are each twice as large as sector A. Okay, and A and B are the same size. Sorry, I missed a piece there. So A and B are the same size. We'll use like the little geometry symbol for put two dashes. Those two are the same. And then C and D are each twice as large as sector A. So I think that seems like they're saying C and D are the same size too, because sector C and D are each twice as large as A, means that 2 times A would equal C, and 2 times A would equal D. So each of them individually are twice as big as A. Assume the needle is spun so it randomly stops in one of them. Find the probability. Okay, so we know that C is twice as big as A, we know that D is twice as big as A, and we know that A and B are equal to each other. So what's the other thing that we always universally know about probability spaces is that these are the only spots it can land. So the probability of each of them has to add up to 1. So let's see if we can take some of this stuff that we know and plug it in here so that we can get down to maybe just one variable. So it looks like we know C is the same as 2A. So instead of C, let's put 2A. We know D is the same as 2A. So instead of D, we'll put 2A. We know B is the same as A. So instead of B, let's put A. So it looks like we're shaping up to be able to figure out what A is. And then A is obviously the same as A. You don't have to substitute anything. So if we get like terms together here, we have 1, 2, 3, 4, 5, 6 A's equals 1. So divide both sides by 6. So the probability of A is 1/6. And you could also turn that to a decimal. I'm going to leave it as a fraction maybe because I'm doing this by hand, so I might as well. And technically, probably in all of these, I should write probability of A, but if you want to write A, B, C, D because it's faster when you're writing the work, it's totally fine with me. Okay, so now we know one of them, and then we automatically know B because B is the same as A, so the probability of B must also be 1/6. And then we know that C is twice as much as A, so 2 times 1/6, or 2/6 would be C. You probably want to reduce that as a fraction, right? So 2/6 is the same as 1/3. So the probability of C looks like it's 1/3. And the probability of D is also 1/3 because it's also twice as much as A. And then at the very end here, I should check and make sure that these actually add up to 100% or 1 if we're writing them as probabilities. Make some room. So to add, I need common denominators. So 1/6 plus 1/6 plus 1/3 is the same as 2/6, and the other 1/3 is the same as 2/6. So I have 1, 2, 3, 4, 5, 6. So 6 out of 6. So it looks like we got the whole pi. So that was just a check to make sure that this actually adds to the whole pi.